So next questions we have the focal length of a spherical mirror is maximum for red light, maximum for blue light, maximum for white light, same for all light. Okay. The question is asking you the focal length of a spherical mirror depends on color. Means color means what? Whenever questions comes in terms of color, so you should think about wavelength. You should think about wavelength. Have you read about any relation related to the focus and wavelength? Have you read any relation about wavelength and focus? Okay, no. So the answer is same for all light. Answer is same for all light. Same for all light. Next questions in front of you. We start with a spherical mirror immersed in a liquid. Its focal length. It's very good question. It's very good question. It's a very good question. Remains unchanged. Okay, so you have spherical mirror. A spherical mirror. Okay, we are talking about a spherical mirror. Okay, we are talking about a spherical mirror. Okay, so I don't want to go that here because I hate to move on. So not changed. Next question we have. Mark the correct options means more than one may be correct here. So minimum distance between real image and the real object in concave mirror is 0. The minimum distance between a real object and a real image in concave mirror is greater than 4f, where f is the focal length of lens. The focal length of concave mirror depends upon wavelength of light incident on it. So the focal length of mirror depends upon medium in front of the mirror. This is a very good question. So you should attempt this question. So correct answer is the minimum distance between a real image and the real object in concave mirror is zero. So next questions we are moving with the two plane mirrors are placed perpendicular to each other. A ray strikes on one mirror and after reflection falls on the second mirror. The ray after reflection from the second mirror will be perpendicular to the original ray, parallel to the original ray, at 45 to the original ray, can be at any angle to the original ray. Again, this is a very good question. So correct answer is parallel to the original ray. Parallel to the original ray. So next question we have, a convex mirror is used to form an image of real object. So, okay, so we are using convex mirror. We are using convex mirror for forming images of real objects. True. Okay, no issue. So we need to find out wrong answer here. We need to find out wrong answer here. So options is, okay, we have the image lies between the pole and the focus, and the image is diminished. Conventionally used to form an image of real object. We are using real. The image is diminished inside. Easy question. It's easy question. Image is real. Okay, so convex mirror used for an image of a real object. Wrong statement is means we need to find out wrong. So image is real. It's totally nonsense and easy questions. Okay. Next questions we have, the phase change in reflected wave when light wave suffers reflection at the interface from air to glass is. So we need to we need to take about change in reflected wave. Okay, light wave suffers reflection at the interface. So reflected. So we need to consider reflections. It will be pi. It will be pi. It will be pi. It will be pi. So basically reflected wave term, so between two is pi. Okay, next questions we have. Due to atmosphere refraction, the stars twinkles, the sun is seen before the actual sunlight and is still seen after the sunset, and the sun appears bigger during sunset or sunrise, and all the. So correct answer is all the above due to atmospheric refraction. The reason behind all this is atmospheric refraction. Next questions we are moving with, when the beam of light travels through medium which has lesser velocity of light, when the value of wavelength and frequency will respectively, okay, increase, decrease, this. So beam of light travels through medium which is lesser velocity of light. Okay, through the medium which is lesser velocity of light. Okay, then the, so basically think if the through medium, okay, which has lesser velocity of light. So velocity of light means, you can think that what refractive index is more, means denser medium, means what, medium is denser. So now you can go through the options and now you can find out the correct answer. So question is talking about wavelength and frequency. So definitely wavelength will decrease and frequency unchanged. Frequency does not depend on medium. Frequency does not depend on medium. So next questions we have, okay, next questions we have this. So go through the questions. Next questions we have, go through the questions. Next questions we have, go through the questions, go through the questions, go through the questions, go through the questions. So next questions, go through the questions, go through the questions. So light of frequency and wavelength traveling with the velocity we enters into glass slab of limited index mu, then frequency, wavelength, and velocity of wave. Okay, in glass slab is easy questions. Again, it's easy questions, very easy questions, but you should know so many concepts to attempt these questions. Okay, so correct answer is, okay, correct answer is frequency does not change, wavelength becomes lambda by mu. So you should know this concept. This concept is very important. Lambda by mu and velocity becomes v by mu. This is very important concept. You should know. Okay, so we are moving for next questions. We have this. So go through the questions. Go through the questions. I'm giving you options and tell the correct answer. So if this is basically what represents the refractive index of a light. Any ray goes from medium I to medium J. So medium I to medium J. So medium I to medium J, then the product is, okay, of refractive this m and is equals to. So see, basically what you are doing, this is the represent refractive index. Okay, so don't take that m is here magnification. Don't take that m is here magnification. Here m is refractive index. Here m is refractive index. So basically what refractive index of medium 1 with respect to 2. So how you can write this refractive index of medium 1 with respect to refractive index of 2 into, you can like this, refractive index of medium 2 divided refractive index of medium 3 and into refractive index of medium 3 by refractive index of medium 4. You see this is cancel out. Basically what m1 by m4. M1 by m4 is what refractive index of medium 1 with respect to 4. You can proceed like this. You can proceed like this. So correct answer is what? So see here we have, okay, 4 m1. So basically this is what 1 by 1 m4. So I hope you have gone through everything. If you don't know, please go through it and then only you can attempt such questions. Otherwise you will feel demotivated and you will think negative about. Okay, leave it. Okay, yeah. So next questions we have. Okay, so the main cause of decrease in intensity of light on diffraction is. This is very good questions. It requires a lot of understanding and easy questions. So go through these questions. I hope you can do these questions. If you can do so, do it. Do it. Do it. Do it. Do this question. This easy question. It's easy. It's easy. It's easy. It's easy. Easy. Yes. So the main cause of decrease in intensity of light on refraction is partial reflection and partial absorptions. So I hope you should know the concept behind it. So I'm not going concept here because I cover other questions. Yeah. So questions, sine of a sine or constant, the value of constant depends upon very good questions, easy questions, doable questions. So I'm going little bit fast here because question is doable. So you have options like this only B and all. So correct answer is A, B, C, D. So constant depends on pair of media, 100%. Color of incident light, wavelength, refractive nature of material. So you have to select all the four. For these questions, you have to select all the four. Next question, we are moving with absolute refractive index of material depends upon nature of material. Okay, this go through the options and so answer is nature, temperature, wavelength of material. So absolute refractive index of material depends upon this. Okay, depends upon this. Next questions we are moving with, okay, a plain glass plate is placed over various colored letters. The letter which appears to be raised least. Okay, so plain glass, we are putting plain glass, so which, okay, raised least. Okay, so that's red. Okay, that's red. Okay. Next questions we are moving for. A hunter desires to shoot a fish whose image could be seen through clear water. His aim should be. Its aim, so it's an easy question to evaluate. It's easy question. Okay, below the operant image of the face, below the operant image of the face. I don't know. Yeah. So a rectangular solid piece placed in the liquid whose refractive index is same as the solid, yo. So basically, we are keeping on a two or solid piece of place in the between who's reflecting the same correct answer. Very easy and very good question. What's the answer? The solid will not see at all. The solid will not be seen at all. The solid will not be seen at all. Next question we are moving with as the temperature of medium increases the critical angle. The critical angle increases as the temperature increases. The critical angle increases. The critical angle increases. Next question we have a ball coated with lamp black put in a glass tank containing water appears silvery due to total internal refraction. So correct answer is total internal. So all coated with lamp black makes a very good version. So keep in your brand it's lamp black. To put in a glass tank containing water appears silvery due to so painful. Question is so painful. Yo. So next questions we are moving with arrange the following combination in increasing order political angles and that. So you have to arrange these combinations in increasing order of critical angle, increasing order of critical angle. So increasing order of critical angle, increasing order of critical angle. Okay. So air water interface, air water interface, air water interface, air glass interface, water glass interface, and air diamond interface. Okay. So air diamond air interface has more critical angle, and air water interface has less critical angle. Only if you know two, you can eliminate it. So now you can ask me how to do these questions. What's the concept variance in the actual questions? You have to know the data given in the book. Then only you can do this question. Then I leave this question. Tell me everyone understood concept is clear. So if you know the data, then only you can do this question. Otherwise, difficult for you to do the questions. Okay. So next, we are moving for next questions. Yeah. So also the formation images in hot deserts. This phenomenon of total internal pressure, air close to the land is hotter than the air from the land. Desert. Air close to land is hotter than the air from the land in a hot desert. Okay, so what's the answer? What's the answer? What's the answer? So go through the correct options. Options are in front of you, and the correct answer is statement A and R. Both are correct. R is the correct explanation. Okay, so air close to land is hotter than the air from the land in a hot desert. Okay. So next we are moving for next questions in optical fiber. So this very good question, doable question. So both core and cladding regions are transparent. 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 In optical fiber, core and cladding regions are transparent. Okay. You should know this concept. You should know. You can take optical fiber in your home. Optical cable nearby your home. You can cut a cable and you can go through it and you can check it. Okay, don't do that. Otherwise, no, your neighbors or even yours, your cable and it's not good. Okay. So no, don't do this activity. Okay, but if you want, it's your choice. But I will suggest you don't do all this thing because it's not good. Okay, so yeah. But whenever you have, suppose you get any optical fiber in your lab, okay, in school, in your college, okay, then you can go through it. Definitely you will see core and clad, okay, and about core and clad, definitely in your school teacher had taught you about all the concepts, okay. It doesn't, school teacher didn't explain all this concept. Go and ask your teacher to why you are not explaining all this concept. Is there my teacher? What are you doing? Class, teacher. What's going in the campus? What's going in the campus? What's so it's anyway, just I'm kidding. Don't. So yeah, so this question is very well. So questions we are moving for next question. Next question we have in optical fiber during transmission of light. So correct answer is no loss or propagation of energy. Touch plastic. Loss, it's very dangerous. It's very dangerous. It will lose the signal. Yeah. So next question we have Fy and Fb are the focal length of convex lens for yellow and blue color respectively. Then correct answer is Fy is greater than Fb. So focus for yellow is greater than focus for blue because you know the relation in length depends how focus depends on wavelength and R. Okay. So next questions we are moving for FB and FR. FB and FR are focal length of a convex lens for blue and red light respectively FB and FR, are the focal length of the concave lens for blue and red light respectively. See, what's the difference? For convex, I'm using a small letter, and for concave, I'm using capital letter. Capital letter, capital letter. We must have you. So first I'm talking about convex, and then I'm talking about concave. See how I can change that? Not at all, not at all. I'm talking about convex. The convex is this, and concave is this. Yo. Yeah, so this is concave and this is convex law. You should know. You should know. It's a good question. It's a good question. You should know these questions. Yeah. So I will should ask your correct answer is FB less than FR, FB less than Bob. What Bob? What Bob? Yo. For both, it's good. It's so okay. So it's correct for both. It's correct for both. So yeah, next questions we have. Next questions. To get real magnified image in the convex lens, the object position is I don't know. I don't know. I don't know. I don't know. You it will happen too far. You're such a nice concept. I don't know at all. I can't understand all this. Hello, hello. How is your life? What's happening in your life? Okay, so today we are going to listen our favorite song. दिल में क्या होता है होता है होता है कुछ कुछ होता है होता है. Hello, so I hope all of you enjoy this song. So we are moving for next question. Yes. So the decrease in the aperture of the lens changes. Decrease in the aperture of the lens, aperture of the lens changes. Yo. So what's the correct intensity of the image? Okay, so decrease in the aperture of lens changes the intensity of the images. Okay, so I hope you know about this. So I don't want to go in depth because I don't have so much of energy to explain on all this. Yeah. Next we are moving forward. Let's just avoid objective is got for convex lens. Take care of the lens because without that you can do so many mistakes. Okay, so lens produced by the images of weight object AB with size this. So BB, but yeah, AR with respect to violet red colors. What's the answer? So size of red is more than violet. Okay, so size of red is more than violet. Okay. So next questions we are moving with, we are moving with, we are moving with, we are moving with, we are moving with. Why gas is illuminated with blue light and convex lens forms a sharp image of it on a screen. If not, the wire gauge is illuminated red light to get a sharp images. Again, the screen must be. So what's the correct answer? So move away from the lens, move away from the lens, move away from the lens, move away from the lens. Next questions we are, the focal length of lens depends on this options you have. You can go through the options, all of the above is correct. The focal length of the lens depends on color of the light, radius of curvature of the lens, material of the lens. Okay, next questions we are moving with. Okay, out of convex, a plano convex, and a concave lens of